So today we are going to talk about exploratory data analysis. In short, we call them as EDA, right? So the acronym is EDA. Fine. So what is this exploratory data analysis? So why we should do this? What is the need of performing exploratory data analysis for carrying out the task of machine learning, right? What is its significance in machine learning or in data science, right? So before understanding about this EDA, the most important point that we need to understand is the problem or the what is the question that is at hand. Let us take the example of a telecom company, right? So a particular ex telecom company has suddenly seen the what you say the rate of customers being coming down, right? The rate of churn rate, the exact word that is the termed is churn rate. So this churn rate is high with respect to the particular ex telecom operator. So the manager, a branch manager or the area manager wants to know, so why this is actually happening, why these many number of customers are leaving away our telecom services and they are porting to a new telecom service, right? So this is a question that was suddenly that was suddenly generated because of this unseen or unforeseen pattern, right? This pattern was not expected by that particular telecom operator or telecom company, right? So when the manager suddenly calls the team and tells he or she would like to know what is the reason, exact reason for this churn rate, for this particular churn rate. So immediately the machine learning team or the project team, let us say, they will devise a quantitative question with respect to the what do you say question that is raised by the manager of the company, right? So there should be a formalism in order to in order to answer this question, and there should be a formal approach, a investigative approach in order to do this, right? So this starts the answer to this question starts by formulating a quantitative question. Please try to understand, we are including quantity in the question but not quality, right? This is an objective approach but not a subjective approach, right? Answering a particular question will be in two forms, either in subjective way or in objective way. So when you are trying to answer these kind of questions, you need to what is stumble upon the facts, right? So you need to work on the facts. So that's why the facts are always objective in nature, right? So you should consider objective approach rather subjective approach. Subjective approach is a what you say is will purely driven is it subjective approach purely is driven by feelings, right, and opinions. So the answer to this kind of question does not care for the feelings or the, let us say, opinions, right? These are not written opinions. This is for the same problem. If there are certain reviews section of there is an option to ask the users to write the reviews. If they have written their experience with respect to that particular telecom company, then also what we do is we will pre-process those reviews, and then we will come to a subject what is a quantitative values. We'll generate quantities, and we will, from those quantities, we will say that this is because of this is happened, right? So the important point is identifying the problem. Once the problem has been identified, formulating that problem in the form of a quantitative question, right? Once the question has been formulated, quantitative question has been formulated, the next important point is collecting the data, right? We are collecting the relevant data. Please try to understand, you are not collecting the data that is irrelevant to the current requirement, the data that is purely specific to the problem is actually collected. And we know very well that the data that is generated in real time is often dirty. What do you mean by dirty? Dirty in the context of data analysis says the data is associated with so many other things like noise, right? Errors in the measurements, right? Calibration errors, and also incomplete data, all those things, right? So the real world data often comes in this fashion. So this is a great challenge for the data engineers in the machine learning team or in the data science team, right? To handle and make the data analysis ready, right? So there are techniques. There are techniques to handle such data in when you collect the data from real time, and we make that data ready. We'll the step that we do to make the data analysis ready is known as data pre-processing, right? So this real world data, as it is dirty, we do data pre-processing to clean the data. And once the data is cleansed, we take the data further for the downstream tasks like machine learning, right? Yes. So here, where this EDA is coming into the picture. Now, once you have collected the data, right? Once you have pre-processed the data, before making the data, submitting to the machine learning task or machine learning, let us say, what we do is we do explore that data, right? We will explore that data. Now, data, we will try to tell so many things, right? If data has got some mouth, it is ready to inform you so much and so many things that it has seen in its life, in its lifetime, in its creation, in its life creation, right? So data, in order to make the data talk, right, in order to make the data talk and tell you what it is all about, we are giving the data the voice, right, and a shape with the help of what is called as exploring the data, right? So yes, data as it is, that as the data as generated and you pre-processed, data is looking nice, it is good, right? It's just pre-processing the data and making the data keeping ready is not enough, because data has got so many inherent patterns and what you say, sudden discoveries you can make it from the data, right? So the question itself is interesting here. The question is why the customers are getting are moving away from our telecom services. That is an interesting question. So obviously data is ready to tell you, right? Data is ready to tell you how to see that, how to know that. It is through EDA, right? It is through EDA. So then what is meant by EDA? EDA is that analysis of data based on numerical methods and graphical tools, right? These are the two techniques that we use to make the data speak for you, right, and tell what it is all about. Okay. So now we know that we are using the data and we are exploring the data. Now, what is meant by data exploration? So please tell me, if we go to a new location, right? If you go to any new location which you haven't seen before, and you want to move to a destination in that new location, right? Destination is present in that new location, and you want to go to that location. You know what you will do? Yes, what you will do?
Search,
Anybody? Yes,
search, search.
yes, you do search operation, right? You do
Yes,
search.
sir. Thank you.
So yes, thank you, you are doing search operation, fine. So when you during that search operation, what you will discover? So when you do search, what you discover? Yes, participants, let me know what happens when you search in a new location. What are the things that you will come to know?
Santosh sir, they're giving the answers in chat box also.
Chat box. Okay, fine,
uh,
fine. I will check it in the chat box. Fine.
Distance between the things.
Okay, so you will find path, and you are saying you will understand the distance between the things, right? And you will understand the environment. You will understand the places. Fine. So here, all these answers are 100% correct. The important different locations. Fine. Good. So all these answers are actually correct. So here, when there are new answers, you are saying traffic also. Good. Destinations, all these answers very much correct. New location, fine. We can attribute, or we can associate, or we can map whatever answers that you are giving in the chat box to our particular what you say exploration the exploration problem also. So if you understand carefully, right? So when you're searching in a new location, the first answer that I got is distance between the things can be understood clearly. Yes. So how much far you are away from a particular thing, or how much near you are away from the particular thing, is pretty well known while you are searching. So in our EDA also, what we do is we will try to come to that position where we will find out how many null values are there in the data. How do we reduce those null values? Is it possible to retain that particular attribute data, or is it possible to remove that attribute data? So the second answer given is we will find path. Yes, this is also true. So here, with respect to the data set that you consider, so the path being the attribute, the grouping of the attributes leading to the class label or class information, right? Leading to the class information. We have the third answer, environment. Yes, as a whole, you will understand from the data set how many number of attributes are there, how many number of rows are in the number of records are there. So in real world, machine learning data sets contain huge number of attributes or features and huge number of records, right? So the size of the data set is fat, right? Fat column and fat row data, in the sense more number of attributes and more number of rows. So like this, you can understand the environment, like shape of the data, right? Next is another answer is places, which we have already seen, different locations. Yes, these different locations, in the sense, if you see, uh, when you are searching in a new place, these already you are in a new place, and from there you are moving altogether in different directions to find different new paths, right? New locations as informed here. So these new paths will let us understand, will make us understand, is it possible to move further, or is there any dead end, right? So that kind of things are also available here, right? So traffic means the density of the data with respect to our visualization in exploration of the data. When you plot the data, how dense the points are located, right? How the points are nearly located, they are located one upon another, or they are present very near to each other. The distance among the points is very less, right? So destination is already known, that is our class label. And a new location, right? New location is already, we have seen that finding the new locations in different locations already seen. And available resources, type of people, right? So here, uh, the resources in the sense, a type of people, these two things are nothing but how you deal with the data, right? How you deal with the data, and how do you handle that data, right? How do you transform a particular data or column in the data, so that the data in that column is is similar to the values present in the other columns, right? Because if you take the example of height and weight of a person, right? So height and weight of a person, height is measured in terms of centimeters, right? And if the uh, let us say height is measured in the centimeters, and if the weight is measured in terms of what you say kgs, right? Is it possible to do any kind of correlation, or is it possible to draw some relation between height and weight? No, because height is in centimeters and weight is in kgs, right? So you make it unique in terms of units. You make the data unique, right? That is called as transformation, right? So yes, we are going to change the slide now. So we I am answering all the questions here, right? Fine. If you see this uh, data, when you do explore, you will come to know so many new things. You will discover interesting patterns which you might not know without plotting the data, right? So exploring the data will make your thought process change, right, regarding a particular thing. So that is the interesting point about EDA, right? When you do explore, the initial disbeliefs about a particular thing will transform themselves to believing the same thing, right? So all those things we can actually observe with EDA, right? So you see in the second point, exploring data for patterns, trends, underlying, you want to know the underlying structure and what are the deviations from the actual trend. Anomalies are nothing but the outliers, right? The behavior of a particular point is different from the behavior of some set of points, right? Behavior of some set of points. If you take the example of credit card fraud transactions, right? Credit card fraud detection, there we have the list of credit card transactions. So among those transactions, some transactions seem to be different in terms of timestamps, let us say, right? So a particular person who will use credit card for doing transactions, like what you say, for paying his or her bills at a particular date, right? At a particular based on the deadlines as specified by the banks or some other organizations, the person, his or her, based on his or her credit card, they will do the transactions, credit card transactions. But suddenly, altogether, on a new day, the credit card has been used. So we cannot directly come to a direct conclusion that this is a fraudulent transaction. So how do you investigate upon that and come to a conclusion that this is a fraudulent transaction and this is a what is a fair transaction, right? So there we do what is called as scatter plot. We do what is called as what is a the analysis, so univariate analysis on a particular attribute, right? Transaction data attribute or timestamps, and we will come to know the strange structures or anomalies in the data, right? So it, as I told you, it helps to discover unexpected things from the data, right? And this is only possible with exploring the data and understanding the summary from the data, right? So here, as we move on, so exploratory data analysis was coined by John Tukey in the year 1977. This has been in contrast to confirmatory data analysis. So what is this confirmatory data analysis? If your data is ready, if your data is correct in terms of measurements and in terms of what is it, deviations, if it is free from deviations, if your data is free from deviations, and if the data what you say calibrate for the help of calibration, if your data is true and it is tolerant enough, right? So then we can test with the help of the data, we can formulate hypothesis and we can generate certain conclusions. So that is confirmatory data analysis. So you can frame the hypothesis immediately, right? Because your data is readily available. Your data is now ready for analysis. So this confirmatory analysis is only possible once you finalize the attributes by using exploratory data analysis, right? So that means EDA is done first, and only after the conclusion of EDA, we will come to a we will come to a state where the attributes are finalized. When the attributes and data are handled correctly, then we can do hypothesis testing and we can make the data available for readily available for machine learning, right? And this guy has also introduced so many basic techniques for plotting and exploring the data, like five point summary or 5-number summary, right? Leaf diagrams, stem diagrams, box plots, and so on, right? So this 5-point summary, we can see when you what is a plot the box plot, because box plot is a sophisticated technique, plotting technique, that helps you to identify the outliers or anomalies in the data, and you can compare the attributes, box plots of the two attributes, by keeping them side by side and understand which attribute data is significant, or significant in the sense which attribute data is better to use and which attribute data is insignificant, right? So this I will come to know how to do this, how this box plot will be visualized, right? So there are various aims of this EDA. The most important being drawing maximum insights from the data set, right? So by using univariate analysis and multivariate analysis. So multivariate analysis means we use two or more than two attributes for the visualization of the data, and we will interpret that visualization, right? The interpretation of the visualization itself is nothing but making the data speak, right? Make the data speak for you, right? So when you interpret that visualization, you will draw insight from that interpretation. What is meant by insight? Insight is nothing but deep understanding about that particular attribute data, right? If it is a univariate analysis, you are trying to understand about that in a more deeper way. So if it is bivariate analysis, you are trying to understand the relationship between two attributes, how much dependent they are in the deeper way, right? And when you are drawing insights, not only you are understanding in the deeper way, you are also quantifying them, right? The understanding is in terms of quantification. Quantification in the sense, you are saying these many number of employees, they fall under credit card default. These many number of employees, they fall under safe zone, like this, right? So this kind of quantification is also present when you draw insights from the explored data, right? So not only you draw insights from the data, but also you uncover the underlying structure, how the data will actually get represented when you plot the data, right? So you will come to know whether the data is densely populated in a particular location, or whether the data points are spread across the region, or are the data points are forming inherent or natural groups within themselves when you plot the data, or due to whether the data is following certain trend, upward trend or downward trend, or that the data possesses no trend. All these things we can understand by visualizing the data, right? So the third one is you extract important variables. This is the most important thing for doing machine learning, because you are doing in some way you are doing dimensionality reduction. So what is meant by dimensionality reduction? As I told you, dimension means the attribute in the data set. Some people say it is feature, right? Some people say it is variable, and so on. So all these terms are same, right? Dimension, attribute, feature, variable, all these are same, right, with respect to the data set. So from among these variables or attributes, identifying the distinguishing attributes that influence the class label, that influence the target label, is important, because the label or the target variable, let us say if the gear is defective. So if I take the example of a defective gear, in order to detect whether the gear is defective or not, we will term it as a binary outcome, right? So a gear is said to be either healthy or defective gear, right? So we represent in terms of binary variable location like 0 or 1. So if 0 stands for let us say healthy gear, and 1 stands for defective gear, right? So this value 0 or 1 is only obtained on the basis of the attributes that you consider for the sake of deriving inherent patterns from the data, right? So we need, for that, from among the list of variables, only few variables or few attributes are actually influencing the class label. So we need to identify such attributes. For that reason, we are extracting those variables, right? And also I told you we can detect outliers and anomalies, right? Strange behaviors. We can test the underlying assumptions. So whatever assumption that you do, right? So this part, testing underlying assumptions, developing valid models, right, determining optimal factor settings, all these things we can perform only when we confirm the attributes, right? Only when we confirm the attributes. So that the third bullet point is crucial, which is about extracting the important variables. If you do that, only then it is possible to carry out the last three tasks, like testing the underlying assumptions, delivering the models, valid models, and so on, right? So we will keep these aims in our mind, and we will will perform the exploratory data analysis, right? And we will answer a few of the, at least if not all, few of these of aims, right? We will realize these aims by performing exploratory data analysis, right? Not all aims will be realized, because the problem at hand might show up altogether a different structure or different points, right? So it might not possible to answer all these aims, right? Right, then. So here, as we see, the goal of EDA with respect to the person who has introduced this concept is to open-mindedly explore data. That is the most important term that you are seeing here, right? The open-mindedly explore the data. So what is this exploring the data in the open-minded fashion? You are not ignoring anything, and you are not hiding anything, right? That is the most important thing. All the attributes, all the variables of the data are readily available, and the data corresponding to that attribute is also available in its way. Please try to understand how the data has been measured or recorded. The data is present in that fashion only, right? You are not modifying anything, in the sense you are not unnecessarily adding up a value in the empty column. You are keeping the empty column as it is, right? Because the data that is understood by doing summary on that empty column or empty cells based column data will also give some information. So that's why we should make the data use in the open fashion, not in the other way. So 1 minute. So there is a question here, right? No question, right? Fine. 1 minute. Yes, we are here. So as the person says, EDA is a detective work. As I told you, it is a detective work. Unless detective finds the clues, you cannot move forward, or judge cannot do anything, right? So judge or jury is a confirmatory data analysis. As I told you, when your data is ready, right? When your data is ready, then you can carry out the hypothesis testing, right? You can carry out the hypothesis testing, whether these attributes are influencing the class label or not. The kind of test that we do, the kind of test that is performed on as a part of confirmatory data analysis is chi-square test. So when you perform chi-square test, it is clear that statistically whether alternate hypothesis is accepted or null hypothesis is accepted, right? So accordingly, when we generally see in the history says in most of the cases alternate hypothesis will get accepted and null hypothesis gets rejected. Why so we will see in the due course of time, right? So once your data is clearly understood, once the attributes are finalized, you can go for confirmatory data analysis like doing testing, hypothesis testing, right? So now now the simple differences between EDA and CDA. CDA stands for confirmatory data analysis. So as I told you, CDA starts with hypothesis, whereas EDA starts with the data, exploring the data, right? So when CDA starts with the hypothesis, it continues to test those hypotheses, right? For the sake of either accepting or rejecting the null hypothesis or accepting or rejecting the alternate hypothesis. So in EDA, if you see, when the data is ready, when the attributes are finalized and data is ready in its complete sense, then only we generate the hypothesis, right? So here, this and last is we do use statistical models, right? We do use statistical techniques to perform hypothesis testing. We right. So I think the myself I am visible in the camera.
Yes, sir. Yes, sir. Yes, sir.
Fine.
You can continue.
Right. Thank you. So, and in EDA, we are using graphical methods in order to generate this hypothesis, right? So, in the sense, these graphical methods helps us to what you say postulate this hypothesis at a later point of time, right? So then, so what are the steps in this EDA? Right, the steps that we perform in the exploratory data analysis are like this. The first step is, as I told you, we must generate a good research question, right? We must generate a good research question, and these research questions can be modified, can be restructured, right, over a period of time, or generally speaking or strictly speaking, whenever you frame a quantitative question, we will consider that quantitative question and we will collect the relevant data. So obviously, whatever research questions that you pose on a given problem, those are fixed, right? Those are fixed. Now, as you have posed a question, quantitative question, you should collect the data, right? Yes, any doubts? Fine. So you should collect the data, the relevant data, and you should do pre-processing, right? As I told you, the data from real world is often noisy and dirty. You should do pre-processing to clean that, right? So once you pre-process the data, what you do is, you next step that you are doing is you are applying statistical techniques or and drawing the descriptive statistics, and also you are using plots and charts to visualize your data, right? So this visualizing the data is all about understanding how the data is structured, right? Whether this data is is telling us any new things or any abnormalities, right? Whether this data possesses any patterns or not, all those things, right? Now once you visualize, once you plot the data, and you will come to know so many different types of interactions, relations, right? And also you also do transformations, right? You also do transformations. As I told you, all the attributes must be in a particular must be in a particular what you say range, value range, right? So because for better visibility, and for better understanding of the data, so if one attribute value is very large, very huge, and if another attribute data is very small, comparing those attribute values itself is a big challenge. So for that reason, you must transform the data, right? You must transform the data, and it all depends on the data that you have, because not always this transformation is required. In some situations, we need to perform the transformation. As I told you in the earlier case, you should see the height and weight should be in same units, right? Or should match in terms of value ranges, right? So then finally what you do is you decide on the hypothesis based on your research questions. That's what. So once you make the data ready, once you finalize upon your attributes, you frame the hypothesis and you confirmatory and you perform CDA, confirmatory data analysis, right? Now, so as I told you, it is EDA. So get conclusions and present your results. That is the most important thing. So hypothesis testing will allow us to understand whether the attributes will influence the class label or not. So accordingly, you will draw the conclusions and you will consider only those subset of attributes that are influencing the class label for machine learning, right? Now, how do we classify this EDA, right? So this classification is based on the discussion or the content that is available in this particular book, right? Written by Sheltman in 2015. So this classification is actually a two-way classification. The first way is about graphical method. The second way is all about statistical method, right? So this, as I told you in the earlier slide itself, we consider that these two techniques to understand more about the data, right? So let us say, if let us consider a small example or a column. Let us say we have the weights of the person. We have the weights of the person. There are 100 values in that weight column, right? So if one particular value, if you do average, let us say, if you consider the average of that particular column, right? If that average is present in between the available values, in between the available list of values or available range of values for that weight column, then it is fine. If the average is, let us say, is below or above the range of values, right? Below or above the range of values, then it means there are one value or certain few values that are actually contributing to this particular deviation in the average. So we should understand what are those values from that attribute, and we should actually handle those values. So the understanding is that such deviate values that are actually deviating this average is only possible through visualization. So that means these two steps will go hand in hand, right? So that means when you do statistics, immediately we generally look to go for visualizing those stats, right? When you perform statistics, you do visualize those statistical data to better understand what is present in the data and what are the patterns or structure in the data, right? So that means these two things will go hand in hand. They are not independent, right? One is supporting the other, right? Please try to understand, right? So non-graphical methods and graphical methods both are required to understand the data, right? So how do we do this? We do this if you are talking about graphical techniques, right? We consider multivariate and univariate analysis to understand about the data, right? So which is the largest value, which is the smallest value, are these values constant across these categories, right? All these things can be done with univariate methods. And in bivariate or multivariate methods, you can try to understand what are the how these attributes are correlated with each other. Is there any strong correlation exist, right? And not only correlation, but also whether these attributes are what you say independent of each other with respect to their particular values or visualizations, right? All those things can be come to know whether these attribute values, let us say if you take the scatter plot for two variables or bivariate in the bivariate analysis, you will come to know how many points are what you say plotted in the dense fashion, right? So the categories, let us say the class label contains, as I told you in the example that I quoted earlier is defective gears. How many examples are falling under defective gears? How many examples are falling under healthy gears? Right? These two things can be clearly understood with the help of either univariate or bivariate analysis. Particularly in bivariate analysis, you consider a particular feature and the corresponding class label, and you do scatter plot and you perform when you plot when you do the scatter plot, then you will come to know how many number of examples are under defective gears and how strong how dense they are populated, right? So now we generally do first univariate analysis, and then we will go to multivariate analysis or bivariate analysis, right? So there are various examples that we will see here. As I told you, you need to first come up with questions regarding the given problem, right? So what are the questions here? How is climate related to location for this particular example? So as I told you, there should be some scenario, right? So the scenario is like this, right? For this scenario, we are trying to understand more about this particular scenario than the data by framing certain questions. Now, these questions might not be research-oriented questions. These questions might be simple questions, right? The range of questions, the level of questions that we generally pose on the data will range from a very small, tiny question to a more sophisticated question, right? So we start with like this, with a very small question like how is climate related to location? Are these clusters present in the data, right? Are nearby cities similar, right? So all these answers, the answers to these questions, right, it is only possible through statistical analysis and visualization. And in for most of these questions, like let us say not if not for the top three questions, right, listed here, we generally use plotting techniques to answer these questions, right? Any doubts here till now? Any doubts? Yes, participants, if you have any doubts, please let me know.
Going good, sir. Carry on.
Thank you. So now, so this is a scenario which is also displaying the number of attributes or variables present in the data set, and also the number of rows, particular number of records falling are listed under these variables, right? So like this, we'll take another real world example, let us say this example like breast cancer research. So there are so many questions that are available to answer. There are so many open research questions in this particular research, right? In this particular to answer the questions in this particular problem, in this particular topic, right? So you see certain questions are like this: does any treatment method result in a higher survival rate? So this question, the answer to this particular question deals with the level of the cancer, that at which particular level the cancer is the patient has which particular level of cancer. Is the cancer is at first stage or second stage, or is it in third stage, or how many levels are there, at what stage the cancer is progressing in the body, right? So according to that, I can answer this question, which treatment helps in survival rate, improving the survival of that particular cancer patient, right? Can a particular treatment be suggested to women with specific characteristics? So this should be understood based on the what you said, the data specific the breast cancer data specific to that particular woman, right? The what you say, the attributes, dependent attributes specific to this particular cancer, and what are the attributes that are actually influencing the progress of this cancer in the body. All those things, like in terms of what you say correlation, and in terms of associations, we need to draw certain conclusions, and we will come to we need to answer this question, right? And also better in this, to answer this question, not only visualization is useful, but also statistics, descriptive statistics also will play a key role here, right? So what is the minimum value, what is the maximum value, we need to understand, right? As a when you, let us say, when you give your blood sample for the sake of concluding for various tests, right? So when the sample goes to the lab, they will do various tests, and they will present the corresponding values for you for that particular test, and also they will show the reference values, right? Reference ranges, right? So these reference ranges are only understood when you do the descriptive statistics on the data, right? Though if the data, if that particular reference range, when any range is is finalized as a reference range, when it becomes a standard, right? And it is already accepted by all the what you say researchers or doctors or practitioners across the globe or worldwide, right? So the answer to the third question is there any difference between patients in terms of survival rates, right? Like are white women more likely to survive compared to the black woman if they are both at the same stage of disease? Now this answer to the answer to this question goes in deep in terms of adding or constructing or attaching new feature, like this the level of what you say this the skin, the characteristics of the skin, right? And also the what you say various other attributes specific to this particular direction, right? Like if you see what is the what are the what is the, let us say BP, or what are the things, or what additional attributes, the attributes particular to the black woman and the attributes particular to the white woman are also to be added here, right? So coming to the third example, right? So you see, in a project investigating the well-being of teenagers after economic hardship, the questions could be in this fashion: is there a positive effect of economic problems on distress? Which other factors can be more related to the distress of teenagers, right? These, to answer these questions, you need to look into the data set, and you need to associate the effect of the what you say value, the effect values to the economic problems, right? And also whether are there any other dependent attributes that are influencing the distress, economic problems and distress, like age and gender, right? All these things are to be taken into consideration to answer these questions, right? Now, so if you consider this like this is another like you see the data, right? So you have the data with respect to cancer information, right? So here you see the patient ID and the gender and the age of that patient, and the date at which the patient has been diagnosed with the cancer, and let us say the some site information which is irrelevant for our analysis, strictly speaking, uh, because these, if you see patient ID and site information, right? So these details are actually unique in nature, right? These details are unique. So unique attributes, if you consider in the analysis part, what happens is you are trying to show all the attribute values one at a time in the analysis, right? So we would like to find the groupings on in the data, we would like to find the categories with respect to the data, not we would like to see individual data items. So that's why in most of the cases, generally this ID and this site information kind of attributes are actually eliminated from the analysis. So wherever the patterns are there, if you see the attribute values, gender, it has only two values, male and female. If you consider the attribute age, it has continuous values, right? Like 58, 16, and so on. So which is very much useful to understand and predict which particular age, if a new person is given as a cancer patient with certain symptoms, right? If a new person is given with certain symptoms whose age is around let us say some 35, right? So our model, whatever model that we learn at a later point of time, should be in a position to predict whether that person is diagnosed with cancer or not, and at which stage the cancer is, right? It is possible, right? Now, so as we have seen these attributes in this particular example, right? In this particular example, we would like to understand various things from this particular data, right? So as you see, there are identifiers in the previous data, there are attributes in the previous data, right? There are attributes measured at subsequent times in the previous data. As you see, these are identifiers, ID numbers, site values are identifiers, right? We also have what? Attributes. What are the attributes that we have? Gender, age, date, and so on, right? These are the attributes, right? If person is uniquely identified with the ID value, so ID is also treated as an attribute, right? Site information contains the information pertaining to a particular patient with patient ID, so it is also an attribute. So all these are said to be attributes, right? So, and these attributes, some of these attributes in this contain date information, timestamp, right? We have time information available. So this time information is crucial to better understand how much the patient is since how many days the patient is suffering with this particular problem. Is it possible to what you say release that patient from the hospital or not? Yes, as you see the participants, if you observe, only few participants are saying that for every 3 minutes the connect it is getting disconnected, and you are saying some of the people are responding that there is some fault connection problems at our end. So we are let us say I'm actually sitting in a location where the bandwidth has no issue, it is clear, and the whatever I speak from my side are actually the data packets that are going from my side are actually receiving to all the other participants who are involved in this particular workshop. So my sincere request to all the participants is to check your internet connection at your end, right? So so that it will be clear from both the ends, from your end and from my end, because when I am continuing with respect to this discussion, right, when I'm continuing from my end the discussion, right, I think almost all the participants they are able to listen, right? So my sincere point request is to check the connection from your end, and please resolve the issue, right? So so thank you. I will simply continue from here, right? Fine. So if you observe the attribute, as I told you, that there will be identifiers in the data, there will be attributes in the data, there will be specific attributes showing specific information like time series or timestamps, right? As you see in this data set, right? Now, now these attributes are holding different types of data, right? These attributes are holding different types of data, and they are also holding different measures of the data, right? So you see, there are two types of variables holding different types of data and measures. Those are continuous variables and categorical variables, right? So if you see, when I go back to the data set, so what are continuous variables and what are categorical variables, you will only tell me once you understand these definitions. Now, what is meant by continuous variable? The continuous variable is a variable whose values are quantitative and numeric in nature, right? Whose values are quantitative and numeric in nature. That is the basic definition that one need to understand, right? So now it is a continuous value holds a number, right? A quantity, right? Which can be rounded off, right? And you can also convert this continuous value to categorical value also. It is through discretization that we do. We'll come to that at a later point of time, right? When it is required. And the other class of variables are categorical variables, right? So what are these categorical variables? These categorical variables are discrete in nature, right? These categorical variables are discrete in nature, and they generally deal with quality information, right? They generally deal with quality information, but not quantity, right? So if you see if I take the example of rank of an officer in military, there are different ranks, though that is nothing but discrete, right? So that is an example of a categorical variable. And also the class label information in the as I am taking the example of defective gates data, the the target label being holding the only two different two values like healthy gear and defective gear, right? Those are categorical, the attribute that is a categorical variable and holding only two values like healthy gear and defective gear, right? So these can be counted. Please try to understand, categorical values can be counted and discrete values are also can be counted, right? Now go back to the attribute data that I have shown in the example. So if you see this in this slide, what is which attribute is a continuous attribute or continuous variable, which attribute is a discrete attribute? I request participants to answer these questions in the chat box. So as per the definition, what a continuous variable will hold numerical data and a categorical variable will hold discrete data, right? Yes, gender is categorical, good. Yes, gender is discrete. ID, age is continuous, right? Age is continuous, true. Age is continuous, correct, right? ID, it is discrete. Please try to understand, ID and site information, those are unique, right? Those are individual, those are unique, right? We cannot say it is continuous, right? So age is continuous, correct, right? Somebody said it is discrete. For which attribute it is discrete? Let me know. And gender is discrete, yes, true, right? Age is said, but is it discrete or not, we should tell, right? Fine, good. So you the participants have understood that what are these attributes, and what types of values this attribute holds, right? What about date? Date is a time date attribute. Please try to understand, it has its own attribute called date and time, right? So you should consider the date and time attribute, right? Understood. So date internally talks about actually the what you say ratio kind of thing, or let us say a difference kind of thing that you can observe, right? In terms of you can convert this date into hours, you can convert this date into minutes, right? We have a date hierarchy, you can use that. Yes, id, you said id is, yes, id is discrete. Date, you are saying date is discrete. Now only I told you date has its own particular attribute, right? Fine, it's a particular type, data type. Fine. Now coming back to the categorical data, as I told you, different examples are shown under categorical data. So ordinal and nominal types of categorical data are present. So right, so you see here, ordinal data talks about order in the for the attribute data, right? As I told you, we'll first talk about ordinal here. You see, the examples given for ordinal are cancer stage, ratings or references, quality of life scales, right? And then number of copies of a recessive gene, right? These are different examples that one can have under the name called ordinal categorical data, which possess certain order, right? We have another set of categorical data which does not possess any order, which is said to be nominal, right? If you take these examples like gender, right, then we have binary data like alive or dead, yes or no, right? We can also have more than two possible values. We can have more than two possible values under nominal data like marital status. So can anybody tell me quickly what are the three values that a marital status can have? What are the three values that a marital status can have? As gender holds uh, male or female, like marital status contains what?
Sir,
Date.
Yes.
Date, sir.
No, I am talking about date contains its own data type.
Okay, okay.
Yes. What are the values that the marital status attribute holds? Please let me know.
Year, sir. Not year also. No.
sir,
So
Santosh sir,
yes, sir.
they are sending their answers in the chat box, sir.
Yes, sir, I'm seeing that answers. Yes, sir. Yes, sir.
Okay.
So almost all the people are saying only are showing only two values, telling two values. Yes, somebody has given three values, right? This is the right answer, right? A person, a marital status holds three values. It could be married, or it could be divorcee, it could be single or unmarried, right? There are three values for the marital status attribute, right? So that's why this particular attribute falls under more than two value attribute, right? More than two value attributes, right? In the same lines, if you consider the attribute religion holds so many number of values, right? So many number of values. Religion attribute. Country of birth also has so many country values, right? So how many countries are there in this world? Those many countries can be shown in a particular data set. Race also has more than two values as opposed to white or black, right? In terms of color. So you can have multiple colors, multiple race information, right? So like this, we can have, we can understand, or we will know what kind of data is present in the data set, right? Initially, when you collect the data, you should first understand what is the type of the data. So for that reason, we are trying to learn more about that, right? So once you understand the data, once you pre-process the data, right, the next thing is plotting the data, right, which is our task here, right? So for plotting the data, what we are doing, we are using the what you see, various plots, and we are summarizing the data, right? And we are trying to interpret them, right? So now the most important thing is this one. Yes. Any doubts?
No, sir. Continue, sir. Continue.
Fine. So as when you do plot, right, when you do summarize the data, first of all you do with descriptive statistics. So the descriptive statistics can be in the form of counting. It could be started with counting the values. So set of values as you're seeing in this particular slide, right? So colon cancer patients are 1,35,400, breast cancer patients are 1,93,700, and so on. Different categories of patients and its corresponding counts are tabulated here, right? So then you can also form a frequency table which will be very clear in terms of total number of values and the relative frequency or the distribution of the patients under each category of cancer, right? That can be known, and it is possible to understand which particular category of patients are which particular patient, how many patients, let us say, which particular cancer has more number of patients with respect to percentage, if you consider, right? That is obviously it is visible with the data also. It is very much clear, confirmed with the help of relative frequency, right? Now in order to plot the data, is it better to use R programming language or Python programming language? That is the choice, right? Which is useful. So this slide will give you clear information whether to go with R or whether to use Python. So here in the last paragraph, if you see, if you are trying to analyze a data set and present the findings in a research paper, then R is probably a better choice. But if you are writing a data analysis program that runs in a distributed system and interacts with lots of other components, it would be preferable to work with Python, right? So here, strictly speaking, it is better we use R programming environment, but still, as we have already informed you, we will work with Python. We will use Python for our understanding, right? So this particular subtle difference is to be known by all of you, right? So just to visualize the data and try to interpret the findings, try to interpret and get the findings from the data, it is better to use Python, because
Yeah, Hari.
sorry, R. It is better to use R. Sir, can you mute yourself? Fine. 1 minute, participants. We'll see. Fine. So see here, as if you want to just see how the data looks like, what is the structure of the data, and interpret and generate findings from that, better we use R programming language, because R contains good number of packages, and for the sake of better visualizing the data, right, in terms of charts and graphs and plots, right? So as we have already informed you that we will use Python, we will use Python for the same. We also has Python also has good number of packages for plotting the data, for visualizing the data, right, for coming up with charts and so on, right? So this is with respect to R. Now when you do plot the data, you plot the data in, as I told you, in two ways, that is through univariate and bivariate analysis. So here what you are doing, you are considering the class label information, different types of cancer data, and that particular data you are plotting the frequency, right? So this is one variable data, the analysis, like this is univariate analysis, cancer attributes, the values of the cancer attribute, right? So what are the values of cancer attribute? Colon, breast, prostate, lung, and urinary, and you are simply showing the frequency, right? So this is univariate analysis, single variable plotting, right? Data plotting here, right? Now continuous data, if you have continuous data, you can do this in order to plot it, right, for the sake of finding relative frequency and grouping the data, right? When you group the data, if you see this example, there are 10 patient data here, leukemia patient data available, and you are grouping them in terms of age groups, right? And now what happens, instead of seeing individual bars, you can see some group of age values falling in a particular width or bin. What is the bin? What are the bins that we have specified? 21 to 30, 31 to 40, 41 to 50, and 51 to 60. There are 4 bins. Under these 4 bins, these 10 patient data age values are actually will get grouped, right? Will be falling in those bins, 4 bins, right? So thereby, what you are doing indirectly, you are grouping the data, and which is nothing but you are categorizing the ages, right, into separate groups, right? This is once again the relative frequency that we all know, right? So when if you see, if you count, there are 2 patients who are falling in the interval 21 to 30, and relative frequency is 20%. Highest frequency being 4 patients in 31 to 40 age group, so 40. So the total is 10, and the relative frequency going to 100%, right? Fine. Now, so continuous data plots, if you want to, instead of doing binning, or if you don't want to do binning, right, you can use different types of plots. But if you do binning or grouping the data, you use what is called as histogram, right? So see the histogram holds the binned data, right? So x-axis talks about ages and y-axis talks about frequency. Obviously, how many people are there in the age group of 21 to 30, how many are in between 31 to 40, this is shown here, right? Then, so this is motor trend car road test. This is a data set that is, you see, this is in R programming language. You are seeing the descriptive statistics, or simply starts with the number of the data type of the attribute, like you see the name of the attribute, the data type of the attribute, and then the values holding by that attribute, right? So then we also has documentation specific to each attribute, what each attribute says, right? And then we can do summary statistics like this. You can find out what is the minimum value, median value, maximum value, quantiles, right? Different quantile values can also be shown here, right? Now, instead of doing all these things, you simply call the method summary. In our programming language, it will show you all these values, right? If you want to find the summary of only first 3 attributes, you should specify like this, right? 1 to 3, for only first 3 attributes it will consider, right? Now, in order to tabulate the counts, right, for individual attributes, you can use a table, right? And that table will tabulate the values for you, treating each and every attribute value as a vector, individual vector, right? And then right, you can make that data into a data frame, right? This is the way you create a data frame, right, using table attribute. Now, yes, now these, if you see, the function names are very much similar when you do plot in Python also, right? There we are using hist here. There I think we use histogram. There we use box plot here. There also we use box plot. So here we use bar plot. There also we use bar plot, right? So like these different plots are there. So right, we will see now what is meant by box plot. Box plot is a visualization or a plotting technique that holds 5-point summary in it for a particular attribute. So if you consider what are the 5 points present in this box plot, right? So this is the minimum value. The first value in the box plot is minimum value, right? The second value in the box plot is 25th quantile, 25th quantile. The third value is 50% quantile, right? Fourth value is 75th quantile, 75% quantile, and last value is maximum value, right? So if you plot, if you do box plot on the attribute data, real world data generally shows up the values below the there are some instances or values from the data which could be lying below this minimum value or lying above this maximum value. Those values which are lying below and above the minimum and maximum values are treated as outliers, because the characteristics of those values are different from the values that are present inside this box plot, right? So now you see, you can also compare the box plots and this comparison will make us understand at what levels the values, the attribute values are there, right, with respect to each attribute. And if you see in a number of cylinders, if there are 8 cylinder data in the miles per gallon data, if you have another attribute called number of cylinders, there is a particular value that is lying less than minimum value in 8 cylinders, right? So which talks about miles per gallon, right? And this particular miles per gallon is not present in the range of values that should be there. Actually, it should be there, which is not present in the range of values. So we treat this value as an outlier, right? Now, so like this, you are doing different comparisons. You can compare 2 attributes, or you can compare more than 3 attributes side by side, right? Right now, histogram, as we have seen already, histogram is used to show the distribution of the data in a particular bin or in a particular group, right? So this is a distribution of the data with respect to miles per gallon of that car, of that empty cars, right? Then we have also bar chart. So this bar chart helps you to understand more about what you say groups in the data, more about groups in the data, right? So these particular groups are plotted with different colors to better understand which group has huge number of values, which group has less number of values, right? So like let us say if you have defective gears values, how many values are said to be healthy gears and how many are defective gears can be understood in a better way, right? Now scatter plot, as I told you, if you want, this is with respect to bivariate analysis. So in bivariate analysis, you are taking 2 attributes and you are comparing, or you are trying to understand the relationship between these 2 attributes, right? What are the attributes shown in here? Miles per gallon and horsepower of the engine, right? So if you see, when you plot these 2 attribute values as a scatter plot, right, there you can see first of all, they most of the values with respect to your intuitive distance, whatever distance that you see, most of the values are in this particular group, right? They form a group here, right? If you don't like to make this another group, you can form this as a total as a single group, right? That's what I say. Grouping, the notion of grouping itself is ambiguous, right? So this, let us say this is another, this is one group and this is another group, and these 2 values are these 3 values are shown extreme, are plotted extreme. So obviously we cannot say these will follow the characteristics of these 2 attributes, right? We can treat these 3 values as outliers, right? So how you are saying manually, that is the most important thing to understand, because just by looking at the plot, is it correct to say that this particular point is an outlier point and these 2 points are outlier points? So for that, we need to find out the range of values. We need to find out the correlations, and the outcome of the correlation will make us understand whether these values are outliers or not, right? Now, so we can do color coding also in order to differentiate one set of values with other set of values. And this color coding is useful in order to differentiate different clusters, right? Different clusters while doing clustering, right? Now, so this lattice graphics is not required for us. We simply skip this and we strictly directly come to our lab scenario, that is defective gears prediction, right? So what I will do is, for the next 10 minutes, I will go to my collab and I will show you how we do exploratory data analysis on this particular data set, defective gears data. So this Python notebook file and the Excel file I have shared with you in today morning in the group, right? So now for the class session, we use these 2 things, and in the afternoon session, we will deal with water pump monitoring system, EDA, right? Fine. What I will do is I'll open my uh, Python notebook. Sir, is the Python notebook visible here?
Yes, sir. Yes, sir.
Okay, so I will
It's
go.
a,
Yes,
sir,
sir.
it is mechanical scenario for classroom discussion. The slide it is.
Okay, so okay. What I will do is I will do one thing. I will stop the share,
Ah,
and
yes, sir.
once again I will share the screen.
Sir.
So before that, we will see, are there any questions raised in the chat window?
No, sir. At present, no questions in the
Okay,
chat box.
okay. So what I will do is I will share my screen now. Yes, exploratory data analysis. Fine. Is the screen visible, sir?
Yes, sir. Yes, sir.
Right. Thank you. Now I would like the participants to log in into your Colab and upload this Python notebook file here. Once you upload this Python notebook file, please let me know in the chat window. Immediately, what I will do is I will make you and I will make you understand how to upload the Excel file directly from this Colab environment if the file size is less. Okay, please respond in the chat box once you upload this notebook file in the Colab. The steps are already specified in the yesterday's during yesterday in the chat in the WhatsApp group. Please refer to those steps in the from the WhatsApp and try to upload here.
Morning, sir.
Good morning, sir. Please tell me, sir.
Kindly, you can repeat the step how to upload this file to Colab.
Fine, sir. What I will do is I will I will show in the screen and I will speak here so that all the participants will be able to do that with me. So participants, please be attentive while I am doing here, and please listen to the way that I will load this into my Colab. Now, the first and foremost step is go to Google and search for Google Colab, right? So go to Google search engine and search for Google Colab. Right. In the search results, you can take either of these two, right? So better I'm taking this one. Welcome to Collaboratory. So you will see this, right? You will see this as a search result, one of the search results. Welcome to Collaboratory. So click on this. So I think all of you are here in this page. Yes. Are you people with me now?
Yes, sir.
Right. So fine. Now we are here in this home page of Colab. Now in this home page at the right side corner, you have a button called sign in. So click on this sign in button and log in with your Gmail account. Log in with your Gmail account. Right. So I'm logging with my Gmail account. Fine. Have does all the people are here? Are all the people here in this page?
Yes, sir.
Okay. Fine. Now if you want to upload a new Python notebook, simply what you should do is you should click on this upload option, and in this you have a button called browse button, right? Click on this button and select which Python notebook you would like to upload, right? So select the corresponding Python notebook.
Santosh sir,
Yes, sir.
you participants are telling that repeat once again. Just from not from starting, just few slides back.
Fine, fine, fine. So I think people have come to this particular location. All the participants, please reply here whether you are in this page or not.
Sir, yesterday one only we opened.
Yesterday?
Yesterday session one is there, no sir. Same one we opened.
Yesterday session,
Sir, actually yesterday evening you have discussed
Sir.
how to log in.
sir, yesterday lab experiment will be once again carried out whenever the time permits, right? I will make you do that. So before that, today we will do this, right? So have you, after logging into your Gmail account, you are here, right? All the participants, please respond, right?
Sir, we are
Yes, sir.
already opened
Yes, sir.
yesterday's class.
Yes, yes.
From
No,
there we want to add.
that's what, sir. If this is for those participants who haven't understood, right? Who are new to this today's session. So for them we are showing, and I will explain now, right? So now
Okay,
what you do is go to the file. There are menu options here: file, edit, view. Click on file and click on upload notebook, right? So once you are here, you click on this browse button and select the corresponding Python notebook file and click on open. So you should able to see the success message and loading message here and the left bottom corner while you upload this Python notebook file, right? So participants are please tell me whether you are in this page or not.
yes, sir.
Fine. Now don't do anything. Don't run the cells until I tell to do so, right? Before that, we should mount our Google Drive, right? With what particular Gmail account you have logged into Colab, you should attach that or mount that Google Drive here. So what is the need of having Google Drive? The Google Drive is utilized to hold your data permanently or on a temporary basis while you are working in Colab, right? So it is the place where you hold the data and you use the data in the form of data path in the program, right? So in order to mount or attach your Google Drive, click on this files icon, right? Click on this files icon. So now when you click on this files icon, you should able to observe there is a change at the right top corner, connecting. Now this message says you are connecting to cloud environment, and the cloud environment is providing you with the RAM and disk space, right? RAM and disk space. So this Colab is a Google provided cloud environment, right? This is a free cloud environment. So you see how much disk is available. So this much amount of space is available with me, right? So I can utilize for my task, right? Whatever task that I can do, I can do here. And there is a visualization on top here, which will tell you the usage of the particular resource from the cloud, right? Now you see, in order to mount the drive, you simply click on this third icon, mount drive option, right? Click on this on the left side. You are seeing this mount drive option. Click on this. Now here it is showing me 2 lines code, right? So what I do is I should run this code first, right? So in order to run this code, there should be RAM and disk available for me. So that's why before mounting itself, it is allocating me RAM and disk, right? Now connect to this Google Drive and provide access to this Google Drive, right? Collab is external to the Google Drive environment. So that's why you should provide access, right? Now, within no time, your Google Drive gets attached to, gets mounted or attached to your Collab environment. So that is visible just by clicking on this refresh icon. So once you refresh this, then automatically your drive is visible, attached drive is visible. So simply click on this to verify whether you have attached the correct drive or not, right? So yes, you from my side, I have attached the correct drive here. So no need to have any problem. I don't have any problem with this. So the same thing is, I assume that same thing is true from your side also.
So how do we know we have attached the correct file?
You should check. That is your drive. You should know that whether are the files shown here are same as the files that I have already uploaded in the drive earlier.
Sir, yesterday you sent a link to login that shows like Unicode, .pdf, OF. That's how it shows. So it's the same file you have to use.
Unicode.
Yeah, I think it's an untitled code. That's what they mean, I think.
It's not a Unicode, ma'am. It's not a Unicode. Today morning I have sent the files here, data files and the Python notebook files for today's session.
Okay.
You kindly check in the WhatsApp group, right? Right. Now please don't run this first cell, because this is for the sake of generating data for EDA, right? As I don't have this data immediately with me, this is generated data. So I am using 100 instances of synthetic data, which deals with defective gear information, which holds only 2 features, right? I will share that Excel sheet with you. I already have shared that Excel sheet. I think you can open that Excel sheet from your side, and you can see what are the values, what are the attributes that the values that the attribute are actually holding, right? So don't run this particular cell. Come down and run this cell, the program, the exploratory data analysis part, right? So before running this cell, we will understand, right? Now, whether this drive is whether the data is present in my drive or not, I need to check, right? Before running this file, before understanding this file, we should upload the data, right? In order to do that, please all of you pay attention here. In order to upload a small data file, you can do it here immediately, right? You can do then and there itself by simply clicking on drive, and here I am seeing my drive here. I am going to the end of this my drive where 3 dots are available, vertical dots. I am clicking on this, and in this there is a option called upload, right? So once again I am showing you, please see here, in this drive I am having my drive option. So I am making the cursor available on that and holding that cursor on that and simply moving to the right side there. There you are seeing 3 dots here. I am clicking on these dots, and there we have so many options available, and in that one of the options is upload, right? Click on this upload, right? When you click on that, you will be asked to upload the data file, right? 5 minutes. You will be asked to upload this data file, right? So click on this data file and click on open, right? Immediately this collab shows you ensure that your files are saved elsewhere. This runtime files will be deleted whenever this runtime is terminated. That's okay, fine, because we need to use this data for this runtime itself, for this session itself. So there is no issue. Simply click on OK, right? Automatically this file will get attached, will get added to your drive. So in order to check whether the file has been added to your drive or not, simply check with the name defective. Yes. So there the file has been attached, right? This file has been attached here, right? You see, this is the file. Now what I will do, I think you people are here now. All of you people are here. Any doubts here?
We will try and do it, sir. Then it will be clear.
Okay, fine. Now what I am doing is I'm simply clicking on these three dots once again in order to copy the path of this file, data file, right? I'm copying this path and I'm writing here. I'm pasting here. So this is my a path where the data resides, right? So why I'm using this path here, I will now tell you, right? What are the packages that we are introducing here? We are using pandas package for holding the data that is obtained from the external environment, like from CSV, in the form of a data frame. And next we are using matplotlib and cborn packages in order to plot the data and show the charts for you, right? So matplotlib is used for plotting what you say various plots which generally deals with the data in the form of matrices in the background. Of course we don't go in depth about that, but we are using that for the sake of plotting the data. And cborn is another package which shows most appealing visualizations, most appealing data visualizations. So that's why we are using these two packages for the sake of EDA purposes, right? Now, first of all, what you are doing, you are collecting the data, right? So what you are doing is you are creating a data frame with the help of pandas package. And this is, as I told you, this PD, PLT, SNS are nothing but alias names for those packages, right? You are using those alias names and you are calling this method read CSV, read underscore CSV. And this method asks you to upload the CSV file, comma separated values, right? So we are uploading that comma separated values with the help of path here and upload it. And I'm printing the information about the data set, right? So once in order to print the basic information, it is upon the data frame, you can do that. So df.info. And if you want to find out the statistical information, descriptive statistics, summary information about the data, you are using the method called describe, right? df.describe. So in R, it is summary. The method is summary. In Python, it is describe, right? That is the difference, right? Describe method. Now coming to this, if you want to check whether any missing values are there, you can use this method, Boolean method called isNull. So this isNull returns either 0 or a true or false, right? True or false. So based on that, this can be counted and they can you can count and you can make that sum also. If there are no values, it will tell there are no value, no null values or missing values, and it will sum it, right? And this is a pair plot, and this pair plot, as you see, it is taken from the cborn package, and this pair plot will show us the information about the attribute and the corresponding defective information, as you see here. So this is pair plot with respect to the two attributes, feature 1 and feature 2, and these dots represent the what you say defective gear information, like healthy gear and defective gear, right? 0 represents healthy gear, 1 represents defective gear, right? So now, so pair plot shows the pairs, the feature information in terms of pairs here. So feature 1 with respect to feature 2 for the, in terms of the two types of gears, right? This is the distribution of the values with respect to the defective gear class data by using feature 1. And this is the scatter plot information. If you observe, this scatter plot does not possess any pattern. It does not show any pattern, right? It is what random in nature. The points are distributed in the random fashion. And here also the points are distributed in the random fashion. There is no pattern as such here, right? In this feature 2, if you see the distribution of the defective gears data with respect to feature 2 is like this, right? So the healthy gear information are more with respect to feature 2 when compared to defective gear information. Here also the healthy gear data with respect to feature 1 are more as compared to defective gears, right? So this is a pair plot which shows the data in pairs, plots the data in pairs, and then we are plotting the box plot. So box plot helps you to identify what particular whether the attribute values have any outliers or not, and what is the 5-point summary about that particular feature data. I am using feature 1. You can modify this feature 1 and replace this with feature 2 also, and that shows you the box plot here, right? Shows you the box plot here. So with respect to feature 1, the highest value is 1 for healthy gears. Maximum value is 1 for healthy gears, and the maximum value for defective gears is less than 1 here, as you see in the box plot. So this is the highest value, right? Right. So then after box plot, and we are using correlation matrix also. So from these things you need to draw insights actually, what these things are trying to tell you, right? So as I told you, there is no trend in this data, and here defective gears are more healthy gears are more than defective gears with respect to this feature, and here also you see positive healthy gears with respect to feature 1 are the highest value is 1 with respect to feature 1 for healthy gears, and it is less than 1 with respect to defective gears. And you see the median value is high for healthy gears, and it is somewhat less for defective gears. So like this, you can draw certain conclusions from the plots. And this is a correlation matrix. This correlation matrix shows you how these features are dependent on each other, how strongly they are dependent, how much strongly they are dependent. You see feature 1 and feature 2 are dependent in this fashion with 0.02 value, whereas defective and feature 1, so there is a negative correlation, right? In between feature 1 and defective, in between feature 2 and defective, there is a negative correlation. That means these two attributes are not actually influencing the gear information. If you want to change the values, so that this calls for modification in the data. Please try to understand, this calls for modification in the data with respect to feature values, so that these defective values will be positive in terms of correlation. If there is positive values, only then it is possible to understand that these features are influencing the class label, right? So you see this warm plot. This colors representation tells you how much high the correlation is. So this diagonal information is about the same feature, so that's why it is 1, right? So you see, with respect to color coding, it is possible to understand. Then we are doing count plot, and count plot, we know how many are falling under healthy gears and how many are falling under what to say, defective gears, right? This is count plot. And finally, we need to draw important features. What we are doing is we are using random forest classifier. So classifiers like decision-tree classifier, random forest classifiers help us to identify what are the important features that are used for the classification purposes. So for that reason, you can either use decision-tree classifier here. You can modify this to use a decision-tree classifier, and you can see which feature is having highest importance and which feature has less importance as compared with the other feature. So in this example, we have only 2 features. So that's why here you see there is a very slight difference between feature 1 and feature 2 in terms of importance. So if we have more number of features, we can actually form a empirical threshold, and that empirical statistical threshold, with the help of that statistical threshold, it is possible to say that the values above this threshold are the attributes which are above this threshold are deemed to be important, and the attributes below this threshold value can be ignored straight away for the machine learning task. So like this, what we have done is we have considered the data and we have performed right, both the statistical analysis as well as visual analysis on this data, and we have drawn conclusions. For every plot we are drawing conclusions, right? So with respect to those features and with respect to that class label information, right? So the only thing is that whether these features are positively correlated with the class label or negatively correlated with the class label is quite important to know whether these attributes are useful for the analysis or not, right? This is a very simple tiny example that I have shown here, so that you will come to know how we generally perform exploratory data analysis. As you see in this data, there are no null values. All the values are filled. All the attribute values are filled. So you see all the attributes are not null, right? They are not null. There are no missing values. The meaning is there are no missing values in each what you say attribute cell, in each cell of that attribute, right? So like this we generally do what to say exploratory data analysis. So in the afternoon session, in the lab session, we will deal with the real world data like water pump monitoring and maintenance prediction. For that, how we explore the data and how we will derive insights from the data, and how we will send the data for the prediction, we will see. Right? Any doubts here?
Okay, participants, if you are having any doubt, you can ask Amma.
Any doubts? I can't see the table. So on my screen, which table, sir? Like descriptive statistics, or that you shows the values. So just to scroll, use the scroll, sir. Use the scroll, and then you will understand the. You're able to see these values. Yes. You see here we have scrolling. I think based on the resolution of your monitor, the scroll button will automatically get added to the screen. So
Santosh sir,
yes, sir.
Santosh, there is a question for you in the chat box.
1 minute, 1 minute. Yes, sir. So, sir, you told EDA is done after cleaning. What is cleaning data and how to do that? Yes. So, EDA, as I told you, it is to be carried out after cleaning the data. Here, cleaning starts with identifying the missing values in the data, right? So, we haven't generated a graph. Which graph here? I will come to your doubt, sir. I will answer your question. So without before plotting the graphs, what we are doing, we are understanding about the data, right? We are understanding about the data. So first, what we are doing is we are actually considering the data set, and we are trying to find out, are there any missing values in the data? So missing values means the cells in that particular column are empty. Some of the cells in the particular column are empty because the measurements might have not recorded, right? Like it is not it is incomplete, are there any faulty instruments that led to incompleteness of the data while recording? All these things are the issues pertaining to missing values, right? When such is the case, the analyzing such data will lead to wrong interpretations and wrong insights. So to overcome or to handle that situation, what we are doing is we are trying to fill those missing values through various techniques. There are various techniques to fill those missing values. One technique being replacing that missing value with the mean of that column, or mode of that column, or median of that column. These are the basic handling techniques to do that. And if you are not in a position to do that, either of these three things, You can do with a machine learning algorithm like regression, linear regression algorithm to predict what could be the value. Like with the help of regression, linear regression, it is possible to do interpolation. So interpolation means the values in the given range can be predicted. So when it is possible to predict the values in the given range, it is understood that the missing value is obtained through prediction. So that obtained value can be replaced in that missing space, and you can carry out further descriptive statistics, right? So not only uh, you are handling the missing values during pre-processing, you are also identifying the duplicate attributes in the data, in the data set. You are also trying to identify how the attributes are correlated with each other, right? Which attributes are trying to have close associations among themselves. All those things you will do during data pre-processing, and you will also eliminate, in some cases you will eliminate the attributes altogether, because that attribute is not at all required for the analysis. As we have seen in the presentation part, we have seen that the ID number of the patient, which is not at all relevant for the analysis. So you can straight away eliminate that column from the data set, right? Irrelevant columns you can identify through your common sense knowledge, and you can eliminate them, right? And if at all, if you are working on a real time, more realistic and real time problem, then you should have a domain expert sitting with you to better understand the attributes, what that data holds, and is it possible to transform, or is it possible to add a new feature, or is it possible to construct a new feature out of the existing features, right? Like if you see, density is an attribute, a new attribute. Let us say density you would like to add to the existing set of columns, and you don't have the density column, but you have mass and volume. You can construct that new column called density by simply creating that formula. Density is mass upon volume, so that you can have a new column created, and that density column can be used further, right? So cleaning has so many things in it. Actually, here in your mechanical engineering perspective and scenario, most of the times you will come up with correct measurements, correct data, until and unless you overlook upon the instrument and the device calibration issues. I don't think you have issues with the data cleaning, right? So fine. Next is somebody said graph is not generated. Which graph I would like to know. And then are there any other questions? So only after visualizing the data? No. We should first clean the data. We should first clean the data. Then only that you should visualize, or you should explore, right? Strictly speaking, you should not say the term visualization for the sake of exploring the data, right? Visualization comes at the end of the analysis of a particular problem, right? For the as I have started with a question, like a manager is asking why these many number of customers are porting to a new telecom operator. When you model that, and when you form a machine learning model and see the interpretations of the upon test data, and if you plot those interpretations, that plot is nothing but visualization. That is nothing but data visualization. Until that point, as we started with the data, and we are working on the data to understand more about it, we are not visualizing, rather we are exploring the data. Please try to understand. This kind of plots are useful to know the structure underlying present with the data, and the patterns and outliers present in the data, right? So these things we will not talk at the time of visualizing the results at the end of the project, right? At the end of the machine learning project, we don't say we found these outliers, we found this structure in the data. No, this is not these are not the point that we speak at the end of the project. We will only say because of these things the customers have left our telecom service and ported to altogether as some XYZ the new service. That is the thing that we say. Any doubts?
Still any doubts among participants?
We can, yes, of course, we can clean the data while exploring also. That's what I said. Cleaning in itself is a big thing, right? Cleaning itself is a big thing. While as that while you are exploring, there is a need to transform the data. There is a need to reduce the number of columns in the data. There is a need to aggregate the data, and there is also a need to what you say, eliminate some what you say, rows from the data. All these things as a part of data cleaning we will do. Now, best example, if I give you the last point for this today's session, the best example that I have is, let us say you have shifted your house from the location X to location Y, and let us say you and your wife or spouse, let us say in general, you and your spouse have shifted from one location to other location, and in the data what happened is, for your spouse the address has been retained as the old address, and for you it has modified to new address, right? That is the first important thing that we need to identify during data cleaning, because when first thing, whether that person is related to you or not is only obtained through the last name of that person. So you and your spouse last names must be same. So when spouse names are, when the last name are same, then it is understood that these two people are related with each other. That means there is some issue with respect to the address of these two persons. I need to cross check with the database, or I need to inform the person to update the customer to update their address. So like that we will modify or we will clean the data, right? Cleaning itself is a very big task. The most of the time in machine learning projects, 75% of the time is devoted only for the sake of data cleaning, not for the sake of performing machine learning. If data is clean, then machine learning is correct, right? So when you give correct data, you will have correct output. When you give wrong data, you will have wrong interpretations. That is what the essence of this data cleaning and EDA. Any doubts? Right. So
Participants, the next session begins at 2 o'clock. Afternoon session begins at 2 o'clock, and the feedback link is shared for separately for morning session and the afternoon session. Okay. So next session begins at 2 o'clock. Santosh sir?
yes, sir.
Okay.
Okay, sir. So I am simply terminating my collab and.
Okay, number participant, then begins at 2 o'clock.
Okay. We will meet again at 2 p.m.
Okay.
Thank you.
Okay, sir.
Right, sir. Thank you.
Hello, sir. Sir, feedback when they will share, sir? Like session wise or afternoon we should fill, sir?
Sir, feedback link is already shared in the.
Sir, feedback
chat
link
box,
will be shared separately for morning session and the afternoon session.
Okay.
Twice it will be shared. So now we have shared the morning session feedback link only. In the afternoon, we'll share the afternoon feedback link.
Okay, sir. Okay, done, sir. Thank you, sir.
Okay, okay, sir.
Thank you. Thank you.